At the start of a week, a coal mine has a high capacity storage bin that is half full. During the week, 20 loads of coal are added. Each load has a volume that is normal with mean 1.5, standard deviation 0.25. During the week, coal is removed from the bin and loaded into 4 railroad cars. The amount of coal loaded in each car is normal with mean 7.25 and standard deviation 0.5. The amounts added to the storage bin or removed from the bin are mutually independent. Find the probability that the bin contains more coal at the end of the week than it had at the start of the week. So, um, 20 loads are added. And if we want to find the total that is added, so each load that is added has a volume that is normal with mean 1.5 and a standard deviation 0.25. So we are interested in the total amount that's added and also in the total amount that's removed so that we can see whether more is added or more is removed. That's what we are asked for. Find the probability that the bin contains more coal at the end of the week than it had at the start of the week. So if A is the total amount added and R is the total amount removed, so you want the probability that more coal is there at the end of the week, which will happen if more is added than removed. So in other words, if we let x to be added minus the removed, then we want the probability that x is greater than 0. Because if more is added, then a minus r will be greater than 0 because a will be more than r. And if we call that as x, then that means probability x greater than 0. So we first start by working with the total amount added and the total amount removed. So if A is the total amount added, since 20 loads are added and each load has a mean of 1.5, so by central limit theorem, the mean of the 20 loads or the mean of the total amount that's added will be 20 times mean of each load. So 20 times 1.5, and that's 30. And then the standard deviation of the total amount added will be the square root of 20 because there are 20 loads times standard deviation of each load. So square root of 20 times 0.25. That was the 0.25 was the standard deviation of each load that is added. Similarly, for the removed, not 20, but 4. There were 4 loads that were removed, and the mean of each was, so this is also 4. So the mean of the load that was removed will be the mean of each load removed times the number of loads removed. So 4 times 7.25, because 7.25 was the mean of the loads that were removed. That's given in the problem. So that's 29. And then standard deviation, not of B, but of R, will be square root of the 4, which 4 was the number of loads that were removed, times standard deviation of each load that was removed. So square root 4 times 0.5, that's 1. And then if we let x to be a minus r, as we said before, we are looking for probability that x is greater than 0. So we need to find the mean of x and the standard deviation of x. So the mean of x will just be the mean of a minus the mean of r from this expression. So 30 minus 29 is 1. And the variance of x will be variance of a plus negative 1 square variance of r, because we know that variance of ax plus by is a squared variance x plus b square variance y. So so the coefficient of a is 1, so it's like 1 square variance a plus negative 1 square variance r. So 20 times, now this is the standard deviation of a, the variance of A will be the square of this, which means 20 times 0.25 square. So 20 times 0.25 square is the variance of A, plus variance of R will just be 1 square, that is 1. Negative 1 square is also 1. And this adds to 2.25. So standard deviation of X will be the square root of variance. Square root of 2.25 is 1.5. So now we have the mean of X and standard deviation of X. So we are ready to apply our normal calculation. Now, since we want probability X greater than 0, so we need to change 0 into Z-score. So like our same formula, it'd be 0 minus the mean of X divided by standard deviation of X. Mean of X was 1, so negative 1 over standard deviation of X was 1.5, so that's negative 0.67. So the probability X greater than 0 is the same as probability Z greater than negative 0.67, which by symmetry of the normal curve is the same as probability Z less than 0.67, and that from the table of cumulative probabilities, 0.67 is this one, 0.7486. And that rounds to 0.75, which is choice D.